Hey everyone, welcome back to the channel. One of the most common questions I get is how we can possibly know so much about the universe when we haven't even explored all of our own planet. It's a great question, and it highlights a fundamental concept in science and statistics: sampling. Just like astronomers can't observe every single star, researchers and businesses often can't survey every single person in a population. So how do they draw meaningful conclusions? That's where sampling techniques come in. In this video, we'll break down different sampling techniques, their pros and cons, and when to use them. Let's dive in. First up, we have the gold standard, simple random sampling. Imagine you have a giant hat, and inside are the names of everyone in your population. You want to pick a certain number of people for your study, so you randomly draw names from the hat. That's simple random sampling in a nutshell. Every single person has an equal chance of being selected, just like a lottery. This method is great for minimizing bias because there's no pattern or preference in who gets picked. Now, you might be thinking, Robbie, do I really need a giant hat for this? Thankfully, no, we've got computers for that. Random number generators can pick out your sample with lightning speed, but there's a catch. Simple random sampling works best when you have a well-defined population and enough resources. You need to be able to identify everyone in your target group, and you need a way to reach them. But don't worry, there are other sampling techniques for when simple random sampling isn't feasible. Let's say you're trying to understand the dietary habits of people in a city. You could use simple random sampling, but what if you wanted to make sure you're capturing the diversity of the population? That's where stratified sampling comes in. With stratified sampling, you divide your population into different groups, or strata, based on specific characteristics. These strata could be based on age, gender, income level, or any other characteristic that's relevant to your research. Once you have your strata, you randomly sample from within each group. This ensures that every subgroup within your population is represented in your final sample. Sometimes you need a sampling method that's a bit more, shall we say, systematic. Imagine you're standing in line for a concert, and every 10th person gets a free t-shirt. That's systematic sampling in action. It's like simple random sampling. But instead of using a random number generator, you use a fixed interval to select your participants. Let's say you have a list of 1,000 people, and you want a sample size of 100. You could choose a random starting point on the list, and then select every 10th person until you reach your desired sample size. This method is often easier and more efficient than simple random sampling, especially when you're dealing with large populations. Of course, there's always the chance that your systematic sampling could introduce bias if there's a hidden pattern in the list you're working with. But overall, systematic sampling is a solid choice when you need a balance of randomness and efficiency. Chapter 4: Cluster Sampling Group Hug for Data. Now let's say you're trying to survey students from all the high schools in a particular state. Going to every single school and interviewing students would be incredibly time-consuming and expensive. This is where cluster sampling swoops in to save the day. Imagine dividing the state into different regions or clusters. Then, instead of sampling individuals from every single school, you randomly select a few clusters and interview students only from those selected schools. Cluster sampling is especially useful when your population is spread out over a large geographical area, or when it's simply not feasible to collect data from every single individual. It's a great way to get a representative sample without breaking the bank or wearing out your welcome. Of course, like any sampling method, cluster sampling has its limitations. Chapter 5: Convenient Sampling, the easy button of data collection. Alright, let's talk about the elephant in the room: convenient sampling. It's the method we all secretly love to use because it's just so darn easy. Need to collect some data for your psychology class? Ask your friends and family to fill out a survey. Convenient sampling is all about, well, convenience. You select participants based on their availability and willingness to participate, which makes it incredibly quick and inexpensive. But here's the catch: convenient sampling is also the most prone to bias. Chapter 6: Snowball Sampling, Rolling Data Downhill. Have you ever noticed how a small snowball can quickly turn into a giant one as it rolls down a hill? That's the basic idea behind snowball sampling. It's a technique used to reach populations that are difficult to access or identify. Imagine you're trying to study the experiences of undocumented immigrants. With snowball sampling, you might start by interviewing a few undocumented immigrants you know or can connect with. Then, you ask those initial participants to refer you to others they know who might be willing to participate. As you continue this process, your sample size grows larger and larger, just like a snowball rolling down a hill. Outrow choosing the right sampling technique. So there you have it, a whirlwind tour of some of the most common sampling techniques. From the simplicity of simple random sampling to the snowballing effect of, well, snowball sampling, each technique has its own strengths and weaknesses, so which sampling method is right for you? It depends on your research goals, population, and available resources. Using the right technique can make or break your study. If you found this video helpful, don't forget to, and hit that notification bell for more insights. Drop your questions in the comments. I'd love to hear from you. See you next time.